Here's a GRE geometry question. Let's take a look. The perimeter of square S is 40. Square T is inscribed in square S. What is the least possible area of square T? All right, well, let's start by making our life a little bit easier and summoning up a square. You ready? Abracadabra. Boom. So we have this square S, right? We're told that the perimeter is 40. And so right away we can say that each side is going to be 10, right? Because the total perimeter is 40, 4 sides, so each side is 10. All right, now we're told, this is where things get interesting, that we have another square inside of this square. It's inscribed. What does inscribed mean? It just means that the 4 corners of this inside square are going to touch the sides of the bigger square. And I'll draw an example of one inscribed square. So for instance, there, and there. We could, if we wanted to, just sketch this inscribed square like this. Boom, boom. And then one that comes kind of down here. Not the best square in the history of squares, but it'll do for our purposes. There we go. All right. So there's square T, right? It's inscribed inside of square S. Now this problem implicitly gives us a little bit of a hint. It tells us that there is some least possible value. In other words, we could draw all sorts of inscribed squares, and I invite you to try that. Draw a bunch of different inscribed squares inside of here. But it tells us that there's one square that has the smallest possible area. Well, what is it? You might be able to kind of guess this intuitively, but I'll show you why, right? The smallest possible square you could draw would be the one that touches these 4 corners, right? Because if I draw any other square, and I'll quickly draw this particular one, right? If I were to draw any other square, the sides would get longer, right? Think of it like if I rotate the square any bigger. The biggest possible one you could draw would be like one that's just shy of being exactly the same square, right? But the smallest possible one, I'm going to bold this one a little bit just to really highlight it, would be the one that touches right at the center of each side of the bigger square, right? So this inscribed square that I just drew here is the smallest possible one that we could draw. Well, if this is smack dab in the middle, that means that this distance right here and this distance right here are equal, so that's 5 and 5, and that this is also 5 right here. And using the Pythagorean theorem or special right triangles, you can say that if this is 5 and this is 5, and that's a right angle, that this is going to be 5 root 2. In the interest of time, I'm not going to run through the Pythagorean theorem or special right triangles, but I would encourage you to take a look at those for the test, right? Okay, so if this length is 5 root 2, and so is this one, right? Because we're talking about squares here, everything's equal on all sides. That means that the area of this inscribed square is going to be 5 root 2 times 5 root 2, the base times the height, or the side times the side. So if I do that, 5 root 2 times 5 root 2, what I end up with is 50. And that is the correct answer. For more GRE tips and tricks, or to sign up for my live online course, follow the link on my profile.